Hello everyone, my name is Garima Kushwa and my topic is big data mining tools and techniques. So today's I am going to present on the topic big data mining tools and techniques. In today's digital era, enormous volumes of data are being generated every second from mobile phones, social media, sensors and transactions. But the real changes is how do we store, process and analyze such massive data to extract meaningful insights? That's exactly where big data meaning comes into play. So, let's begin by understanding what big data actually means. Big data refers to data sets that are too large and complex for traditional systems like relational databases to handle. It is often described using the 5 V's. First is volume, second is velocity, third is variety, fourth is veracity, and fifth is value. So, first is volume. Volume is which indicates the size of data, and second is velocity, which means the speed at which data is generated. Variety means which represents different type of data like structured, semi-structured and unstructured. Veracity means to the trustworthiness or accuracy of the data, and value means which means extracting useful insights from decision making. For example, every minute, million of social media posts, YouTube videos, and online transactions generated terabytes of data. That's big data in action. So, now we discuss about the big data architecture. To handle such massive data efficiently, we use a big data architecture, which typically has multiple layers. First layer is data source layer. This includes mobile apps, IoT devices, sensors, social media, and enterprise systems. Second layer is data ingestion layer. Tools like Apache Flume collect and transfer data into the system. Third is storage layer. The data is stored in HDFS. HDFS means Hadoop Distributed File System or NoSQL databases. Fourth is processing layer. Here technologies like MapReduce and Apache Spark perform distributed computation. Fifth is analytics layer. Machine learning models and statistical tools analyze patterns and correlation. Sixth is visualization layer. Tools such as a Power BI present the result in dashboards or reports. Each layer plays a critical role in managing and extracting insights from big data. Now we are discussing about what is a data mining. So, now let's move to the concept of data mining. Data mining is the process of exploring and analyzing large volumes of data to find useful patterns, relationships, and trends. There are some typical steps included. First is data cleaning to remove noise and errors. Second is data integration from multiple sources. Third is data selection to choose relevant information. Fifth, Fourth is data transformation into suitable formats. Fifth is mining to apply algorithms and extract patterns. Sixth is patterns evaluation. And finally, knowledge presentation where results are visualized for decision makers. For example, an e-commerce company might analyze past sales data to predict which products will be in high demand during the festival. Now we are discussing about the big data mining techniques. There are several techniques used in big data mining. Let's go through the most common ones. First is classification. This technique categorizes data into predefined groups. For instance, classifying emails as spam or not spam. Algorithms used included decision tree, naive Bayes, and random forest. Second is clustering. Here, data points are grouped based on similarity without predefined labels. For example, grouping customers based on purchasing behavior. Common algorithms are k-means and DB-scan. Third is association rule mining. This binds relationships between variables. Example: customers who buy bread also tend to buy butter. Fourth is regression. It helps predict a continuous value like house price or sales revenue based on other variables. Fifth is anomaly detection, identifying outliers or unusual patterns. For instance, detecting credit card fraud or network intrusions. This techniques allows organizations to uncover deep insights hidden in massive datasets. Now we are discussing about the big data mining tools. To perform these techniques efficiently, we use specialized big data tools. First is Apache Hadoop, an open source framework that allows distributed storage and processing across cluster of computers. Its main components are HDFS, MapReduce, and Yarn. It's ideal for batch processing. Apache Spark. Second tool is Apache Spark, faster than Hadoop because it performs in memory computations. It supports real-time streaming and machine learning via machine learning libraries. Third is RapidMiner, a user-friendly drag and drop tool for predictive analytics. And next is Orange, an open source visual programming tool that combines data visualization and mining capabilities. Each tool has unique advantages depending on the scale and type of the data. Now we are discussing about the emerging tools and frameworks. As technology evolves, several new frameworks have emerged to meet modern data challenges. Apache Flink for real time stream processing at large scale, TensorFlow and PyTorch, deep learning frameworks for complex data mining like image and text analysis, MongoDB and Cassandra, NoSQL databases designed for unstructured data. Databricks build on Spark for collaborative data analytics. Snowfall and Google BigQuery, cloud platforms offering high speed big data analysis. These frameworks are shaping the future of intelligent data systems. Now we are discussing about the applications of big data mining. So let's see a few real world applications. First is healthcare, predicting disease outbreaks and recommending personalized treatments. Second is in e-commerce, product recommendations and customer behavior prediction. Third is in finance, fraud detection, risk management and credit scoring. Fourth is smart cities, traffic monitoring, waste management and energy optimization. And fifth is social media, sentiment analysis and trend prediction. And last is cybersecurity, detecting unusual patterns to prevent attack. So big data mining is not just about numbers, it's about making smarter decisions in every domain. There are many applications of big data. So now we are discussing about the challenges in big data mining. So big data is a data which is comes from the many sources. So there are some challenges of big data mining. Despite its power, big data mining faces several challenges. First is data quality. Data sets often contains missing or noisy information. Second is scalability. Handling petabytes of data efficiently is still difficult. Third is privacy and security, ensuring compliance with data protections laws like GDPR. Fourth is integration, combining structured and unstructured data from multiple sources. Fifth is skill gap, lack of trained data scientists and engineers. Sixth is cost, high infrastructure and processing cost. To overcome these, organizations and adopting cloud computing, parallel processing, and automated ML pipelines. Now, last is a conclusion and future trends. To conclude, Big data mining is transferring the way organizations operate. It helps turn raw, unorganized data into valuable knowledge that drive innovation and strategies decisions. The future trends included: the first is the integration of artificial intelligence with big data. Second is edge computing for real-time analytics on devices. Third is quantum computing for faster data processing. Fourth is AutoML for automated model creation. And last is a stronger focus on data ethics and governance. Data is the new oil, and big data mining is the refinery that turns it into value. Thank you.